What's up, fellas? It's your boy Nacho. Today we're going to be going over a study by Maroc and colleagues from 2018. It's going to be called The Myonuclear Domain Flexibility Challenges Rigid Assumptions on Satellite Cell Contribution to Skeletal Muscle Fiber Hypertrophy, okay? So, what is the myonuclear domain size limit? You guys heard me talk about this all over my channel. I have a lot of videos talking about the myonuclear domain size limit and how it's linked to satellite cells. But if you guys don't know, basically each myonuclei governs a domain of cytoplasm. So your muscle can only grow to a certain extent before needing new nuclei to expand that domain limit. And so in this paper it says, well, the old assumption, domain size, is fixed. And you guys will see in this study, there's a bit of a nuance, They're saying that, well, your muscles have flexibility, so you can still grow without new nuclei, but there's still a ceiling limit. So they're saying, well, the domain size, it's not fixed, but it actually is. That's what I basically got from this study. And when it comes to hypertrophy, we're talking about myofibrillar hypertrophy, and that's going to need new myonuclei from satellite cells to keep expanding this limit. And the study is going to try to challenge that assumption. Okay. So with this study, their objective is to examine whether myonuclear accretion is required for hypertrophy, meaning do we need nuclei from satellite cells to grow your myofibrils, okay? So this study is gonna focus on type 2 muscle fibers in humans and rodents, because your type 2 muscle fibers have the most potential for growth, not your type 1. It's gonna be your type 2. Your type 2 are gonna be your explosive muscle fibers. And this study is gonna explore satellite cell roles beyond fusion, like ECM remodeling, like I explained in my past video, extracellular matrix remodeling. So here are some key findings from the study. They found that these subjects, they were untrained. Of course, a lot of studies are untrained, but these subjects were untrained and they had significant hypertrophy without myonuclear accretion. So they had these people train without gaining new nuclei. With the nuclei that they already had, they were able to grow their myofibrils to a certain point. So the myonuclear domain is flexible but not rigid, it said in the paper. Meaning you can still grow within that limit. It's just more flexible than we thought, but there's still a limit that you hit. So there's no ceiling that has been proven, but there's likely an upper limit that this paper said. Yes, exactly. We knew this. We knew that there's a limit and you need more nuclei to get past that limit. This paper is just showing that you can grow within that limit with your existing nuclei. So it's not as black and white as you may think, where you can't grow at all without your existing nuclei. That you can, there's some leeway. You can push that limit a bit. It's more flexible than we thought, but there's still an upper limit. So there's still a myonuclear domain size limit, pretty much. And we know that satellite cells respond to damage and not hypertrophy itself, because you can stimulate your muscles all you want, like what people do in the gym. They're training their muscle 2 to 3 times a week. They're stimulating growth without damage, but you're not going to bring the satellite cells out of quiescence when you cause no damage eccentrically. when he calls no DOMs eccentrically, pretty much. So satellite cells is more than fusion. They do more than fuse with the muscle fibers, donate myonuclei. They support ECM remodeling, extracellular matrix remodeling. I explained this in my last paper review, where the ECM is the scaffolding around your muscle, supporting muscle growth. So you need ECM remodeling along with myofibrillar remodeling to get full remodeling, basically. And these satellite cells are going to respond mostly to inflammatory and damaging stimuli. So something that it's going to respond to an unaccustomed exercise that you give yourself, eccentrically. What we found in this study as well is that myonuclear accretion, is not always necessary for hypertrophy until limit is reached. So yeah, like you can grow with your existing nuclei, like I said, but there's still going to be a limit that's reached. So this is especially in trained versus untrained lifters in type 2 and type 1 fibers. Well, your type 1 fibers have less potential for growth. Your type 2 fibers will have more potential for growth. So in untrained, you will grow more within this limit, of course, but in type 2, you need more nuclei, of course, if you're trained to get past the limit. So the key point of this study, domain flexibility is real. Okay. You can grow within the limit, but there's still a limit. It's just more flexible than we thought. Hypertrophy, you don't need immediate nuclei to grow, of course, but the domain can max out. And satellite cell fusion is eventually required for growth. That's the key point. So if you read this study and you're like, oh, we could grow without myonuclei. We can grow without adding new nuclei. We don't need muscle damage. We don't need this. Yeah, you could grow for a little bit, but it's the domain will still max out. And you still need satellite cell fusion to get past that domain. Okay, context matters. Fiber type, we're chasing type 2 muscle fiber growth. Training age, if you're older, your satellite cell accretion, your satellite cell activity will be lower than if you were younger. And mechanical stimulus, meaning the load you give your muscles eccentrically matters. If it's not enough, if you don't cause damage, then you're not going to bring these satellite cells out of quiescence. So what does eccentric overload do, okay? It's going to cause the highest mechanical tension and structural trauma. Eccentric overload gives each muscle fiber the most mechanical tension out of any method because you're lifting more than what you can handle for multiple reps and sets. This is going to target your type 2 muscle fibers, which are more flexible for growth, have the most growth potential. We're going to trigger ECM disruption, extracellular matrix disruption, and we're going to activate the satellite cells. We're going to bring them out of quiescence. When you do that, they fuse with the muscle fiber. You're going to go through sarcomerogenesis, where you grow sarcomeres in series and in parallel, and myofibrillogenesis, meaning these satellite cells are going to fuse with these damaged myofibers and grow these myofibrils and even fuse together to grow a new myofibril. So when it comes to eccentric overload versus frequency-based models like push your basic training a muscle twice a week, 2 to 3 times a week, what everybody does in the gym, they train the muscle multiple times a week with no damage. The frequency model relies on motor unit recruitment. If you guys see it on Instagram or social media, you have it's a new trend where people are saying you need max motor unit recruitment to grow the myofibrils. We know That's not all true. But myonuclear accretion is more inflammation and damage dependent. Yes, you need to cause damage eccentrically to get these satellite cells to donate their myonuclei. And eccentric overload is going to repeat that stimulus that causes satellite cell proliferation. Eccentric overload is you being untrained week by week, meaning you are unaccustomed to that load eccentrically week by week to bring these satellite cells out of quiescence and to proliferate and differentiate. So in all these studies where you see that, all these untrained lifters, when they first exercised and they got DOMmed, they got an influx of satellite cells and they went through sarcomyogenesis and myofibrillogenesis. We're trying to repeat that stimulus week by week. We are trying to be that untrained lifter week by week by giving us an unaccustomed exercise week by week. I don't know if it sounds complicated. If you guys have any questions, let me know. So these frequency only models may avoid the very stress that activates satellite cells. Yes, because they're not causing muscle damage. They think training a muscle more times a week is going to grow their muscle fibers, but they will grow to an extent, like we read in the study, because they're going to have flexibility within that domain, but the domain will be hit, and it's going to be hit very fast. The repeat about effect kicks in very quickly. So you need satellite cells to get past that limit consistently. And that's pretty much it, fellas. If you guys have questions, let me know. What this study was going over pretty much is that, yes, you can grow without nuclei, but to a certain extent, and there's still a limit, and you need to get past that limit. This study was tested on untrained lifters. So yes, obviously they're going to grow initially, but they will hit their domain size limit. You need more satellite cells to donate their myonuclei to keep expanding that limit. So eccentric overload is what we're doing to further expand that limit week by week. Okay, I'll see you guys later. If you guys have any questions, let me know. Like, subscribe, share. Let me know what you guys think about that.